It's time for some more styropyro. We're going to be looking at, I built a long-range laser turret in my yard. I've already gotten a ton of requests for this video, so this should be interesting. That looks so cool. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's get right into this.
Hey guys, it's Drake here. So I just bought this sketchy laser welding and cleaning system. I'm just dying to screw around with it. Now this thing has an output power of 2,000
Always loves
watts,
enthusiasm.
which will make it the strongest CW laser I've shown you guys yet.
2,000 watts for a continuous wave laser? That's a lot. So the ones you see a ton of are the little pulse ones, but the ones you'll see megawatts even on a handheld, but that's just because you're dividing by an ultra small number. But this is a sustained continuous wave, 2 kilowatts. That's up there. And class 4 is 500 milliwatts. So we're several order of magnitudes above the most intense / dangerous laser classification.
How do I really have enough things to clean and weld to justify buying this thing? Of course not. I just want to screw around with a kilowatt class laser system.
That's awesome.
I mean,
2
seriously,
kilowatts.
this thing's approaching military levels of power and laser system. I mean, seriously, this thing's approaching military levels of power and fun.
Military
Plus,
levels
with
of
some additional
fun.
optics, I'm hoping to convert it into a long-range.
Military levels of power, sure, but military levels of fun reminds me of the beatings will continue until morale improves. And mandatory fun time. Was never in the military, but I've heard stories about those sort of experiences.
Directed energy device. Oh, I have a ton of mischief planned for this laser. Now first, I gotta give credit where it's due here. I only bought this thing after watching the Backyard Scientist video on a similar Chinese-made system. I had seen these systems advertised online, but I didn't believe the power claims. His video showed me that I was wrong, and that fiber laser tech is simply more affordable now.
I haven't seen that particular Backyard Scientist video. Let me know if you want me to do a reaction to that. But I have seen some of Backyard Scientist stuff, and he's definitely up there in terms of this sort of crazy stuff.
Definitely watch his video, because he did some pretty creative stuff with his system.
Deleting $1.
Anyway,
basically.
It's my turn to abuse one of these systems. But before I convert this thing into something that'll put me on another watch list, I should test out its intended functions first. Can I really use this thing?
How many watch lists can you be on? I mean, I'm sure I'm already on a few watch lists just by, 1, with the nuclear engineering degree, 2, with having worked at a nuclear power plant and being licensed to operate it. But I'm pretty sure styropyro's got me beat by many, many watch lists. That's not something I want anyway.
Strip off rust using nothing but light? One way to find out. Let's see how well it can clean this rusty air cleaner. Here we go. Am I supposed to, like, wave it around or something? Oh, wow, it's literally melting the concrete. That's amazing. Whoa. Oh, duh. I was probably supposed to use a non-zero scan width. It would have helped if this thing came with a manual. Let's try that again.
There we go.
Ha, there we go.
That beam just looks so cool. It looks kind of sci-fi in a way, just that it's this wave motion gun looking thing.
Oh, that's fun.
Let's clean it up.
Oh wow, it did a great job at cleaning off the rust. Look how shiny that is. This is a great opportunity to clean one of my favorite barrels.
Oh, here we
It's gotten
go.
quite rusty recently and could really use a shine up.
At the nuclear plant, I can't say we ever used any of these for rust or corrosion control or anything like that. Something about requiring everyone in the immediate vicinity to wear intense IPPE. Not exactly the most efficient way to conduct operations, but hey, it sure looks cool.
Oh, that is satisfying. Now I gotta say, I'm shocked how bright that beam is in person. Now the laser light is actually completely invisible, and my goggles block it anyway, but it's heating up particles in the air to a white-hot incandescence.
That makes more sense, because I knew the beam had to be invisible.
It's giving that air glow. That's
2
pretty
kilowatts.
terrifying. Let's see how well the laser can strip off paint. Wow, look at that.
Instant.
It even left the surface beneath shiny. So, how can light strip off paint and rust? Well, when there's so much power being blasted into such a small area, the surface will literally explode off, and this effect is called laser ablation. In fact, the power density is so high here that it makes the core of a nuclear reactor seem tame in comparison.
Actually, no. Well, you'd have to focus the 2 kilowatts in pretty tight. Now, this laser does have a lot of energy in a very small area, so as you're seeing here, the width of that beam, a few inches. Commercial nuclear power reactors, so you'll see power density typically measured in the order of kilowatts per cubic inches or cubic centimeters. And at the low end, we're talking maybe 5 kilowatts per cubic centimeters. And you're seeing the effect of this laser, 2 kilowatts over surfaces and depths that you saw in like the barrel, the stripping the paint off, that are on the order of several cubic centimeters. So, afraid not. This is very intense, but on average, commercial nuclear power reactors, it just has an even more incredible power density. If you're not familiar with that analogy of kilowatts per cubic centimeter, another way of putting this is nuclear energy is about 16,000 times more energy dense than coal. Even if you're not looking at power reactors, you're looking at experimental research reactors. Some of those, when you get into the actual fuel, have been upwards of 10, 15, 20 even kilowatts per cubic centimeter. And again, we're still talking low enriched uranium, as in 5% enriched or less. So nowhere even remotely close to the energy density you would see in, say, a submarine. So unless styropyro is referring to something like this live-action rendition of Minecraft, Chicago POW 1, the first ever nuclear reactor with a power level of a whopping half watt, nuclear reactors still have way more power density.
Slow-mo shows that the laser is actually scanning as opposed to producing a continuous line, which maximizes the power density and ablates the material most effectively. In the case of rust, there's some cool chemistry going on as well. I have some red iron oxide here, which is the main component of rust, and it's only barely affected by this strong magnet. Now let me hit it with a laser.
Didn't stand a
The
chance.
magnet is covered in powder now, and blobs of the dark product keep flying towards it as they cool. This happens because the red iron oxide was reduced to black iron oxide, which is much more ferromagnetic. This reaction only occurs at very high temperatures, which means the laser is really cooking here. Clearly, this thing can heat stuff up to absurd temperatures. So now I'm curious to see what all I can burn
Love how
with it.
enthusiastic he is.
I've got a piece of steel plate here. Let's see if the laser can burn through it. Oh wow, that didn't take long at all. Let's try a piece of drywall. Jeez. I would have
through the
expected
board
the gypsum in
behind
there
it.
to hold up better, since it has a high melting point and it's also quite reflective. But obviously, it's not nearly enough to stop the laser.
Doing nothing. The board behind it's getting more effective.
Maybe this fire brick can hold up to the beam.
Lasted a few seconds.
I'll take that as a
Split
no.
second.
So, how well do you think a mirror can defeat this laser? Oh, this could end horribly.
Dude.
Oh, that was actually easy. Let's try something a bit more challenging.
Row of mirrors. Just
These mirrors
vaporizing
are
the
a great
glass.
example of how every bit of reflectance matters when working with powerful lasers. Absorbing a few percent of incident light may not seem like much, but this is a 2,000 watt laser, so a few percent of that is more than enough to obliterate that thin reflective coating.
Give you a sense, most microwaves are half that, and it's within the whole microwave oven by itself, whereas he's concentrating this 2,000 watt to a very small area.
Take out the glass in the process. I've got some thermite here.
Oh boy.
Now, this stuff is so hard to ignite that you can actually buy it pre-mixed and have it shipped to you without crazy restrictions. Typically, you need a special mix to get it to start burning, But I'm wondering if the laser spot can get hot enough on its own. Alright, here we go. It lit instantly. That's impressive. I need to point out that this thing is not a typical welding hood. It's specifically a laser welding hood. And yes, this distinction is extremely important when it comes to protecting your eyesight.
It's good he's going over
When
safety.
lightning strikes sand, it melts into a channel of glass called a fulgurite. Now I want to see if this laser can do something similar. I'm hoping this white sand can absorb enough light to melt.
This is similar to what happened during the atomic bomb test at the Trinity site. I'm sure you've seen in the Oppenheimer movie. But that had a similar sort of white sand, so this should be interesting.
And here we go.
Look at that.
Oh yeah, it definitely melted.
Yep.
Look at that. Made a nice little glass column there.
Little
The
glass
outer surface
spike.
is crumbly, but the inside seems pretty solid. Now it looks even cooler when illuminated with a visible laser beam. I like that. Other forms of glass have been so easy to melt that I figured
Check
fiberglass
that
might
out.
be interesting. And sure enough,
Yeah.
the laser was able to compactify it into a little bead. This laser is great at cleaning iron, so I can't help but wonder if it can clean sodium metal as well. This stuff is nice and shiny when it's freshly cut, but it quickly oxidizes in air.
Sure.
I'm hoping the laser beam can strip off the oxides faster than they form. This seems like a bad idea.
It does.
Whatever. Ooh, I like the pretty flashes of yellow light there. That's nice.
Yeah, sodium
I'm not sure
burns
if it's
yellow.
actually doing anything, though. Oh yeah, it looks worse than when I started. Oh, that sucks. I guess I'll just try drilling a hole through it instead.
Now, focused into a point like that I'd have to look and see how thick that is, but that could get you some pretty high power density relative to a commercial nuclear power plant.
Wow, this stuff is surprisingly resistant to the light. It's barely doing anything.
Look at that.
Oh, heck. It melted. Oh no, it went under the leaf too. Oh, that's a problem. Well, it was worth a try at least. See ya.
There you go. Because it
Alright,
reacts with
I've
water.
got one more thing I want to try burning. This is a rod of tungsten, which has the highest melting point of the metallic elements. Let's see how well it holds up to the laser.
Oh, that's cool.
Oh, it's drilling into it. Oh wow, that's incredible. Hitting tungsten with the laser produces a ton of blue light. Now, I'm not sure if that's because of tungsten atomic emission, or if the plasma jet there is simply blue hot.
I'm not actually sure either. For those of you who don't know, atomic emission occurs when atoms absorb energy and then release it as light. So electrons in an atom get excited, and then when they return back to their normal state, they emit light, and depending on what it is, in this case he's using tungsten, each light has specific colors. And that's one of the ways you can actually identify certain elements by looking at what colors they emit when they have light, when the light gets emitted after it absorbs the heat. And that's one of the ways you get fireworks to make all those pretty colors. That's why fireworks use the right mixture of so many different types of chemicals.
Hot enough to keep burning even after removing the beam. That's awesome.
It's like a candle.
Alright, now I'm bored. Well, I mean, burning stuff up close is fun and all, but I want to burn stuff way off in the distance. Now, unfortunately,
Wow.
the beam spreads out too rapidly to be much of a fire hazard from very far, although this problem can be fixed. Contrary to popular belief, laser beams do not travel straight. Thanks to diffraction, a laser beam
sure.
traveling even through empty space is going to spread out, which means its burning ability
The air.
shrinks rapidly
Look at the
from the
sight.
source.
What even is
It
that
is
one?
physically impossible
I think
to
I've seen
completely
that one yet.
overcome this. However, there are ways to minimize it, and my favorite way is using a 400-year-old invention. Way back in 1609, Galileo
Telescope?
built the first refracting telescope to magnify images of distant
That's what I
objects like
thought.
planets. Looks like I'll be building a telescope. This isn't my first time combining a laser with a telescope. 5 years ago, I built my laser telescope blaster. And I'll be building a similar PVC-barreled adjustable scope for this laser as well.
That's
The main
so
difference
crazy.
with this one is that the source laser here is 2,000 times more powerful.
Wow.
Between some dubious napkin math and the only suitable optics that I could find on eBay, I threw together this cursed thing. I'm gonna start with something close and work my way out.
That's close?
All right,
okay.
here we go.
That's pretty good.
I didn't really need the telescope for that. Let's double the distance for this shot. Here I have some spicy chemicals that I want to try igniting. Alright, this one shouldn't be too bad. Gosh, it's hard to aim this thing.
That's some range, though. All right, so wouldn't want to mess with this guy. You're either going to get lasered or electrocuted if you try to mess with this guy. It can be used as personal defense or military-grade fun or what have you.
Extending the distance once again, I'm going to try setting this block of cardboard on fire. Gosh, this one's going to be hard.
Looks heavy, just trying to steady your aim like that.
Am I
Or
hitting
bulky,
it?
rather.
Gosh, it's so hard to aim this thing. Oh.
Zeroing it in.
Wow. Yeah, this thing is not easy to aim. It looks like I'll run into trouble trying to hit things much further than this. This isn't like a shooty stick where the aim only needs to be correct the moment the
What is he doing with that? A shooty stick, and he's like, up in a tree. He's using his feet.
pulled.
Of course.
The laser
Of
has
course.
to be held steady long enough for the target to heat up. If you've ever tried free-handing a laser pointer on a far
Yep.
wall, you'll see it's hard to keep a small spot held on a target.
Cat doesn't
guess
want
I
to
need
go
some
after this
added
one you're playing
stability.
with, though.
In order to have a better vantage point, I built this tower. This angle ensures that the ground terminates
This is
the
a
beam
security
and prevents
tower.
the ray of destruction from leaving my property.
This is
Unfortunately,
crazy.
I didn't get in many tests before my scope burned up. The mirror in the welding head reset itself off-axis, scorching
That's
the PVC
far.
and optics. I ended up cutting the wires to the mirror motor to prevent this from happening again. While waiting on my replacement optics to arrive, I threw together a less impressive scope with lenses I had on hand, and I climbed back up the tower on a foggy evening to test it out.
In the fog.
I decided to try out my camera in full
Is that
spectrum,
Illuminati thing?
and I was stunned by the result. My camera is only weakly sensitive to this laser's wavelength.
That looks cool.
Yet it still managed to unveil the actual beast at hand.
That
Even
is
without
amazing.
careful focusing, the laser can easily set fire to my fence about 70 meters in the distance. Clearly, the backup scope is still worth playing around with for the time being. I think it would be fun to try shooting a hole through the door on that truck back there. Well, not that one. I like that old semi. It's that one back there that's
Oh,
the old
wow.
junker. And here we go.
Dude.
Is it doing anything? Oh yeah, I see something lighting up there. Oh, it's definitely burning at least. Wonder if it's actually enough to cut through the steel. Let's take a look at the damage.
That's insane.
Oh yeah, it definitely drilled through there. That's impressive. After the fog lifted,
I don't even know.
I switched back to filming invisible light mode on my camera, which means the laser is back to being invisible the way it is in real life. I found this bottle of trash in my basement when I moved in. It looks like the mice chewed up the top a bit, but I think it's still pressurized. So yeah, I want to try blowing it up with the
What?
laser. Please put me out of my misery.
That was awesome. As someone who loves puns, I love it.
I hope I didn't blow it up with a test shot there. But there's that bottle of nasty wine. And here we go. Oh, I missed.
Got the top of it. Figured that would be harder to hit.
Cool.
Just took it off. Very precise.
That's hilarious. Just burnt the top off. I'm not gonna lie. This feels like the kind of thing that they make new laws about. Let's see if I can open a can of soda from this distance as well. Here we go. Ha! Nailed it.
Splash.
I love how from this view, the can of soda seems to explode for no reason at all. That's crazy. Something I've always wondered is, what are you supposed to do with empty aerosol cans? I mean, there's always a little bit of gas left in them, so I've always just
Shoot 'em
stabbed
with a
them before
laser,
throwing them in the
obviously.
trash. I'm wondering if it'd be safer to use the laser to pop them from a distance. This
As far as safety is concerned, considering you're further away from the thing, and as long as you're using proper laser safety versus, poking safety or sharp object safety, I mean, it really just changes what kind of PPE you're supposed to use. If you're far away from the target and you're protected from the laser with eye protection, sure.
Here we go.
There, ooh! Dude. Okay, yeah, if you're gonna... I can see the use of a longer ranged laser to do something like that that can burst into flame and jump at you like that. Man.
It was. Wow. Well, it seems some branches are blocking my path here, so guess I'll just trim them down. I used to laugh at all the suggestions I get for building a tree trimming laser, but this actually seems to be a useful technique. Of course, lasers introduce a lot of major hazards that you don't have to deal with when doing mechanical trimming.
Yeah, like fire.
And the upfront cost is substantial. But even so, I can certainly think of situations where a laser tree trimmer is appealing. This can of insulation foam quit spraying on me. I'm not sure if it's because it's clogged or maybe it's solidified on the inside. Well, either way, let's open it and find out what's wrong. Oops. Alright, now here we go.
That's cool.
Yeah, it didn't seem to spray out a bunch of stuff. It must have simply be solidified in there.
Shoot it more and see what happens.
Maybe it was just clogged, considering how much of it sprayed out on the fence there. Let's see if I can burn a hole through this clay pot. Alright.
I'm not sure where he lives or anything, but it's good that he has a nice amount of property to play with. Hopefully he doesn't live right next to his neighbors and there's a fair amount of distance. That's what's nice about being in some of these locations.
Let's smoke this pot.
Wow.
Oh, there it goes.
And well, you are. Different type.
Oh yeah, it cracked. I'm quite impressed how easily I can melt ceramic from this distance, even with the weaker backup scope.
That's pretty cool.
I should have held it on just a little bit longer. It melted through the front, and it nearly made it out the back as well. Thermite was easy to ignite from close range with the laser.
Tried from long
so now
range.
I want to set it off from a distance.
Dr. Pepper full of thermite.
Here we go.
Sounds like a nasty practical joke.
Wow, instantly.
Yeah.
I want to reiterate how hard it typically is to ignite this stuff. So the fact that I can set it off instantly from this distance is pretty amazing. My new optics arrived, which meant I had to take apart the scope to put in the new ones. Unfortunately, I had epoxied it together, but I was able to defeat the polymers using jujitsu. Yes!
I don't even...
Oh yeah. I rebuilt the scope back to its original higher power density specs. Alright, I've got the new scope built here, and this time I've added a camera on top. That way my shots will be less shaky for you guys. So the switch on the welder actually broke, so I had to wire on this new one here. But the nice thing about this one is that the laser will shake less when I fire it, which means it'll be easier to hold the spot on the target. For the first test with the upgraded optics, I'm going to try melting through this piece of drywall from 70 meters away. Let's see if I can hit this thing. Oh wow.
Didn't stand a chance.
That was really quick. I think it shot straight through there. That's amazing. It was hard to keep the beam steady from that distance, but the laser still melted straight through. The aiming laser spot there shows how wobbly the tower is, and that problem is way worse when I'm up in it. Let's try something a bit harder this time. I have this fire brick that I melted through earlier from close range. Let's see if I can do it from 70 meters. I gave the brick a solid 30-second blast from the laser, hoping that the raw power of the beam could make up for the rickety mount that the laser is sitting in. I can't tell if I melted through it or not. It's melting. It's certainly melting there. I should go check on it.
Power density is so high, considering how small this hole is. I can't quite tell how big the hole is, but it's at least closer than I thought versus what I said earlier in this video.
It did in fact make it all the way through the fire brick, melting an impressive portion of it and turning it into glass. Clearly, the laser spot can still reach some extreme temperatures even at this distance. Alright, that's actually pretty insane. Because that is just light. That's wild.
It's light. It's radiation.
Now I just know you guys are going to comment on that propane tank. And believe me, every day the urge is there to light that thing on fire.
Oh my.
However, it wouldn't exactly be very responsible of me.
Seems pretty close to your
light
house.
this thing on fire instead. No way.
That's cool.
The laser punched through the steel wall super quickly. However, it wasn't able to provide the flame needed to actually ignite the gas. I decided to give it another try, and was able to briefly ignite it
something.
by keeping the laser firing at the leaking tank.
I guess that's part of it because it's so eating. It's different than like just keeping a flame there right in front of the gas, but you can get something out of it.
Alright, I'm going to try taking another shot at that truck door back there. I'm hoping it goes even faster with the new optics. The laser cut through the steel much faster this time, producing a nice shower of sparks in the process. I also gave the tire some love as well, but that thing hadn't been inflated in a decade, so I couldn't get it to pop. At some point during the aiming process, I accidentally set the inside of the truck on fire. Oh, heck.
I accidentally set the truck on fire. That's awesome.
It's on fire in there.
I like how unconcerned he sounds. He's just takes it in stride.
That's a problem. Well, unfortunately, it seems I've lit that truck on fire in there. I better put that out. That ought to do. See?
Never change styropyro.
Yeah. Alright, where's my gasoline can?
It's your guess.
Well, nearly burning that truck to the ground reminded me that I really need to burn that brush pile behind it. Gosh, I've been meaning to do that since I've moved in.
Figured he has a burn pile. That's good.
Alright, here we go.
Nice. A nice safe way to light your burn pile from 70 plus meters away. That's good.
That was fun. Now the thing is, burning stuff at 70 meters is cool and all, but I didn't go through the trouble of building a frickin' tower-mounted laser cannon just to toss some photons over a rock-skipping distance. Oh no, my craving is to burn things so far away that I can just barely see them.
What was the distance on that?
Yeah, that was a bit dramatic for moving out to 220 meters.
20 meters.
But it's more than triple the distance of the last shot.
That is impressive. He is quite well prepared to defend himself.
It's as far as I can go without having to worry about stray beams leaving my property. I started with some easy pyro targets to get a hang of these long shots. What am I hitting? Wow, and I thought 70 meters was hard to aim. This is brutal. Yes, I got it.
There you go.
Wow, that was
That's
a launch.
insane.
For the next shot, I'm going to see if I can ignite this roll of firecrackers.
So imagine yourself, you're just walking through this forest, and then out of seemingly nowhere, some firecrackers just go off. Because you can't see this laser. I know he's using a specialized camera to be able to see it. And then suddenly things just start exploding, and you can't even see where it's coming from. You can't trace it. It doesn't make noise, not like a gun or anything. So that'd freak me out.
It's close. All right, just a little bit to the left.
It's got the sophisticated
Other left.
adjustment system here.
Yeah, there it is, I think.
There you go.
Yes! Awesome! I was able to open a can of soda from 70 meters, Let's see if I can do it again from 220. Did I get it? I can't tell. I just can't tell. This one was a bit anticlimactic, but it did manage to pop at the top of the can. Alright, I'm gonna try burning through some drywall once again. If I could get this aim right here. Oh, this stupid mount is so wobbly. It never wants to hold the spot on target. Yeah, I can see it glow. I don't know if I actually shot through it or not, though. Let's go check. It looks like I didn't make it through that one. I don't think the optics were at fault there. I can see it started to melt. I just couldn't keep the spot stable enough for it to go through.
Sure.
These popcorn tins are about the only good thing about the holidays. I'm gonna try melting through one from this distance. Oh, I got it, I think. Oh yeah, I absolutely got that thing. Absolutely. You can see it glowing, haha. I don't know if you can see it from this view. I was barely able to make it through that one. Now that's made of steel, and even though it's thin, I still consider that pretty impressive.
Yeah, and at that distance.
I figure I might as well give thermite a...
The fact that he can get any melting on that at that distance is impressive, because lasers still follow the inverse square law, which is you double the distance, intensity drops by a factor of 4. Plus, as he described earlier, atmospheric absorption, reflection, and scattering. So if you were to apply the inverse square law to this, your calculation's not gonna be right just because of a lot of the real factors. But if this happened in a vacuum, it would be the inverse square law.
Even though this one will probably be a stretch. No. I managed to ignite the plastic container, but that flame temperature is far from being able to ignite the mix. It turns out my issue was just in the aiming. Once I had it aligned with the exposed powder, it went up in flames within seconds.
Especially at night.
I didn't actually expect this one to work, but I'm glad I tried it because it turned out to be a nice surprise. I've got one more thing I want to zap from this distance. It's just another pyro target, but it should look pretty nice since it's getting dark out.
Styropyro target.
Oh, I can actually see the aiming beam now. Can get that right on there. Yeet.
Yeet? Really?
Oh yeah, that'll do it, won't it? I'm gonna have to cap the experiments here just because, I mean, I'm sure the laser could go much farther. In fact, it can go way further than this.
Oh, I'm sure.
The problem is, I just don't have a place where I can shoot it and confidently know that the beam's gonna stop and not leave my property. Now that being said, I think it's worth looking into the theoretical max distance that this setup can burn. So using the Stefan-Boltzmann law, as well as the auto-ignition temp of paper, and some other approximations, I get a max burning range of 4 kilometers, or 2.5 miles.
Wow, that's a lot. For those of you who don't know, the Stefan-Boltzmann law states that the total energy radiated by a black body, which isn't exactly real, it's an approximation, it's an ideal case that absorbs and emits all frequencies of electromagnetic radiation, is proportional to its temperature to the 4th. In other words, as it gets hotter, it emits more energy in the form of heat and light. It's directly proportional to temperature raised to the 4th power and directly proportional to the surface area. The rickety tower isn't stable enough to make a shot like that, but this is still a crazy result.
That is. That means that with a good mount and a bigger telescope, you can hit a point where the curvature of the Earth is what puts a cap on the burning distance.
That's awesome.
That's crazy. Oh, and one more thing on the topic of burning stuff. I can already foresee the comments saying, oh no, he's gonna burn the forest down. So a couple things on that. So for one, I'm an expert at burning things in the woods, all right? Like seriously, growing up,
burning
that's like
things
all
in
I
the
did with
woods
my friends was
expert.
just light things on fire in the woods. But also, this isn't California where just looking at the forest will light it on fire. It rains here, right? In fact, we actually had a bunch of rain this past week. So like, The risk of lighting this forest on fire is zero, and that's no exaggeration. Like, I couldn't light these woods on fire if I tried, and that's saying something.
I was gonna say, he would.
So that's about all I have for this video.
I always love these new styropyro videos. This one, man, the range on that thing is insane. And yeah, there's definitely some military applications here. So I think we all know who's gonna survive these sort of end of the world scenarios. Thank you very much for watching. I'll see you next time.